Overview. Aircraft with a maximum operating altitude of 35,000 feet are fitted with a microprocessor-based pressurization controller, which controls cabin pressure automatically using two outflow valves. The controller automatically schedules cabin altitude during climb and descent up to a maximum of 8,000 feet at an aircraft altitude of 35,000 feet. Following a controller failure, cabin pressure may be controlled manually. Automatic protection facilities are available to control maximum positive and negative differential pressure and maximum cabin altitude. Cabin pressure information is indicated on a separate display. Introduction. Bleed air is supplied to the passenger cabin from the air conditioning packs. Cabin pressure is controlled by regulating the amount of air allowed to leave the cabin through the outflow valves. These are electrically signalled and pneumatically actuated. An air supply from any engine or the APU must be available for their operation. In automatic mode, the system operates using one of two channels to control the outflow valves. In normal operation, the primary channel controls the primary outflow valve, with the secondary outflow valve pneumatically slaved to it. Should the primary channel fail, the secondary channel will automatically control the secondary outflow valve with the primary outflow valve slaved to it. This is indicated by PRI on the controller and pressurization on the central warning panel. The normal controller display can be restored by pressing Clear Display Fault. Should the secondary channel fail, SEC is indicated on the controller, and the primary channel will be unaffected. If both automatic control channels fail, Dual is indicated on the controller, and Pressurization illuminates on the central warning panel. The cabin pressure can be controlled manually using the Mode selector switch and the Manual Rate knob. The system is normally operated in the Auto mode, with the outflow valve selector in the normal position. The outflow valves are controlled automatically to maintain comfortable rates of climb and descent in the cabin throughout the aircraft's operating range. Two outflow valve annunciators illuminate when the respective valve is fully open. The intended landing altitude can be set using the landing altitude control. Landing altitude is displayed on the quad gauge and on the controller. The controller display will revert to cabin altitude after 5 seconds. Cabin rate of climb, differential pressure, and cabin altitude are displayed on the pressure controller and the quad gauge. Following failure of automatic control, manual mode is entered by pressing the Mode control button. Cabin altitude is held constant, but can be controlled by use of the manual rate control knob. When operating in manual mode, pressurization is displayed on the central warning panel, with manual rate on the quad gauge and MR on the pressure controller. On first rotation of the manual rate knob, selected cabin rate of change is displayed. Due to cabin rate of change being referenced to sea level, at high cabin altitudes, actual rate of change may be different from selected rate of change. After 5 seconds, the display reverts to actual cabin rate of change. Selecting Ditch on the outflow valve selector overrides automatic and manual control and closes both outflow valves in preparation for a landing on water. Selecting Dump fully opens both outflow valves. Both these selections illuminate pressurization on the central warning panel to indicate abnormal operation. Protection. The software of each control channel includes cabin differential pressure protection in both automatic and manual modes. If differential pressure exceeds 7.35 psi below 27,000 feet or 7.45 psi above 27,000 feet, the controlling channel will demand a rate of climb to reduce differential pressure. Above 7.6 psi, differential pressure flashes and pressurization illuminates on the central warning panel. If differential pressure continues to increase, pneumatic protection within both outflow valves limits maximum differential pressure to 7.7 psi. Pneumatic protection within each outflow valve limits negative cabin differential pressure to minus 0.5 psi. Below minus 0.5 psi, differential pressure flashes and pressurization illuminates on the central warning panel. If the cabin altitude exceeds 8,700 feet, cabin altitude flashes until the Clear Display Fault CDF button is pressed. If the cabin altitude continues to rise, the cabin altitude display will flash again at 9,700 feet, and cabin high altitude will illuminate on the central warning panel. The CDF button will not clear the flashing display. The controller has a built-in automatic test facility. This is performed on power-up, continuously during flight, and after flight. If a failure is detected, the appropriate failure code is displayed on the controller display. A failure not requiring pilot action, such as a single channel failure or single ADC failure, is accompanied by a white pressurization caption on the central warning panel. A major system failure requiring pilot action, such as a dual channel failure or dual ADC failure, is accompanied by an amber pressurization caption on the central warning panel. Each failure code displayed on the controller may be cleared by one push of the CDF button. However, the amber pressurization caption remains lit. The system may be tested manually on the ground by turning the landing altitude knob below -1,000 feet by 5 clicks. Pass is displayed on the controller display if no faults are found. This test is normally a maintenance action, but may be used to test the controller display if there is any doubt regarding its serviceability. A ground pressurization switch on the ground test panel allows ground functioning of the pressurization control system. When pressed, an integral warning light illuminates, the weight on wheel switch is overridden, and the outflow valves may be closed. External checks. The condition of the primary and secondary outflow valves should be checked. Pre-flight. When the batteries are selected on, all the segments of the quad gauge should be checked serviceable as the system self-tests. After AC power has been applied to the aircraft busbars, the ground pressurization button on the ground test panel should be pressed to confirm that the filament is functional. The button should be pressed again to disable the ground test facility. The pressurization controller is set up by checking the outflow valves are selected to normal and mode is selected to auto. When APU air is available and selected on, air is supplied to the outflow valves, and the annunciator should indicate that both valves are fully open. In ground mode, both outflow valves are held fully open to ensure that the cabin remains depressurized. On the quad gauge, cabin altitude should indicate airfield elevation. Rate and differential pressurization indicate 0, and landing altitude will indicate current airfield altitude. Landing altitude may now be set to the destination airfield elevation or 8,000 feet, whichever is less. In flight. The pressurization system transfers to flight mode when either the number 2 thrust lever is advanced to a takeoff setting or a speed of 160 knots is exceeded. To prevent pressurization surges, the cabin is pressurized to an altitude 200 feet below takeoff elevation. Cabin altitude is increased in accordance with the climb schedule. No input is normally required to the system during flight. However, before descent, the intended landing altitude should be confirmed set. If the landing altitude is greater than 8,000 feet, it may now be set up to a maximum of 9,300 feet. Any pressurization abnormality. A system failure requiring pilot action is indicated by amber pressurization. If pressurization is accompanied by either dual, indicating a dual control channel failure, or ADC, indicating a dual ADC failure, manual mode must be selected. When operating in manual mode, cabin rate of change should be set between -300 feet per minute and +500 feet per minute to maintain passenger comfort. After 5 seconds, the display reverts to actual climb or descent rate. When descending in manual mode, cabin and aircraft altitudes should be equalized shortly before landing. If the warning was due to cabin differential pressure being in excess of 7.6 psi, monitor differential pressure. If 7.8 psi is exceeded, switch off the packs selectively to control cabin pressure. Before landing, both packs should be switched off and the outflow valves selected to dump. If the warning was due to cabin differential pressure being less than -0.5 psi, cabin air should be selected to fresh to attempt to pressurize the cabin. Before landing, both packs should be switched off and the outflow valve selected to dump. If amber pressurization is not lit, any fault code on the controller should be recorded and then cleared by pressing CDF. Loss of cabin pressure. Following a loss of cabin pressure, cabin high altitude will illuminate when the cabin climbs above 9,700 feet. Oxygen masks should be donned and communications established before it is confirmed that the outflow valves are selected to normal. Cabin altitude and cabin rate of climb should be checked before an emergency descent is considered. Limitations. The maximum operating altitude is 35,000 feet. The maximum pressure differential up to 27,000 feet is 7.5 psi. Above 27,000 feet, the maximum differential pressure is 7.6 psi. Following a loss of software differential protection, the maximum differential pressure is 7.7 psi. The cabin differential pressure must not exceed 0.1 psi during takeoff and landing.